An infinite sequence is a function whose domain is the set of positive integers. It is often shown as a sub n. An infinite series is an expression of the form sigma of from n equals 1 to infinity of a sub n equals a sub 1 plus a sub 2 plus a sub n. Here are all the tests used for numerical series. So for the first question, state whether the series is convergent or divergent. So since there's a factorial in this series, we're going to use the ratio test. So limit as n approaches infinity of the absolute value of n plus 3 factorial times 4 to the n plus 2 over n plus 2 factorial times 3 to the n plus 1 times n plus 1 factorial times 3 to the n plus 2 over n plus 2 factorial times 4 to the n plus 1, which equals the absolute value of n plus 3 times 4 over n plus 2 times 3, which equals the limit as n approaches infinity of the absolute value of 4n plus 12 over 3n plus 6, which equals 4/3, which is greater than 1. So this series. So this next question is the sigma from n equals 0 to infinity of 10 to the n plus 1 over 2 to the 4n plus 1. So we're going to use the ratio test again. So we're going to take the limit as n approaches infinity of the absolute value of 10 to the n plus 2 over 2 to the 4n plus 5 times 2 to the 4n plus 1 over 10 to the n plus 1, which equals the limit as n approaches infinity of the absolute value of 10 over 2 to the 4th, which is less than 1, so this series converges by the ratio test. So the next question is the sigma from n equals 0 to infinity of negative 1 to the n times 5 times n to the 2n over 4 to the 2n times 2 times n to the 2n. We're going to test for absolute convergence here, so we're going to take the absolute value of this series and then use the roots test, which gives us the limit as n approaches infinity of the absolute value of 5 to the 1 over n times n squared times 4 to the 2 times 2 to the 1 over n times n squared, which equals the limit as n approaches infinity of the absolute value of 5 to the 1 over n over 4 to the 2 times 2 to the 1 over n, which equals the limit as n approaches infinity of the absolute value of 1 over 16, which is less than 1. So the series converges absolutely by the roots test. Find the sum of the series of the sigma from n equals 4 to infinity of n minus 2 over n cubed minus 3n squared minus 4n plus 12. So to find the sum of this series, we're going to have to cancel out terms from the numerator and denominator to see if this is a telescoping series. So to do that, I'm going to use the box method, and I find out that it does work, and n minus 2 is both in the denominator and numerator. So you end up with the series of the sigma from n equals 4 to infinity of 1 over n minus 3 times n plus 2. Now we're going to have to break up this series using partial fraction decomposition, or PFD. So setting up the PFD and cross multiplying, we get an plus 2a plus bn plus 3b. We have to set that equal to 1, and we end up with a equals 1/5 and b equals negative 1/5. So we end up with the sigma from n equals 4 to infinity of 1/5 over n minus 3 minus 1/5 over n plus 2, which equals a telescoping series. And once you cancel the terms out, you get 1/5 plus 1/10 plus 1/15 plus 1/20 plus 1/25. So use the sum of the first 4 terms to approximate the series. Part B is estimate the error of the series of the sigma from n equals 1 to infinity of n over n to the 4th plus 4n squared plus 4. So the first 4 terms equals 1/9 plus 1 plus 2 over 36 plus 3 over 121 plus 4 over 324, which equals 0.20380573441. The remainder of the first 4 terms will be less than or equal to the integral from 4 to infinity of n over n to the 4th plus 4n squared plus 4. So we're going to factor out the denominator to get the integral from 4 to infinity of n over n squared plus 2 times n squared plus 2 dn. We're going to use u's up here to solve this integral. So we set u equals to n squared plus 4, which means that du equals 2n dn. Simplifying this integral, we get 1/2 times the integral from 4 to infinity of 1 over u cubed. So that means the remainder of the first 4 terms will be less than or equal to the integral from 4 to infinity of 1 over 2 times n squared plus 2. To solve this, we need to plug n equals 4 into the integral. We get the error of the first 4 terms is less than or equal to 1 over 2 times 16 plus 2, which means the remainder of the first 4 terms is less than or equal to 1 over 36. Find the radius and interval of convergence of the series of the sigma from n equals 1 to infinity of negative 1 to the n times x minus 1 to the n times n plus 2 over 2 to the 2n plus 1 times n plus 1 factorial. We get the limit, using the ratio test, we get the limit as n approaches infinity of the absolute value of negative 1 to the n plus 1 times x minus 1 to the n plus 1 times n plus 3 over 2 to the 2n plus 3 times n plus 2 factorial times 2 to the 2n plus 1 times n plus 1 factorial over negative 1 to the n times x minus 1 to the n times n plus 2. We get the limit as n approaches infinity of the absolute value of negative 1 times x minus 1 times n plus 3 over 4n plus 2 times n plus 2, which equals 0. So therefore, this series converges everywhere. Since the series converges everywhere, the radius of convergence equals infinity, and the interval of convergence is from negative infinity to infinity.